Okay, so our first theorem here is going to be that in a domain, the cancellation law holds. And this is the defining characteristic of a domain. So suppose that R is a commutative ring. Then R is going to be a domain. Oops. If and only if for all A, B, C in R, with C not 0, AC equals BC implies A equals B. That is, we can cancel non-zero C's. And it's an if and only if. So domains imply cancellation, and cancellation implies domain. Okay, so you should think about this as a sort of a characterization of domains among commutative rings. Those commutative rings where the cancellation law holds. Let's go with the forward direction. Suppose R is a domain, so there is no zero divisors, and it's a commutative. It's a commutative ring, and it's non-zero. And we have three elements of R where C is not 0. And then such that AC is BC. We need to show that A is equal to B, right? Well, let's take AC as BC, and let's subtract over that BC. So AC minus BC is 0, and then let's distribute out or factor out the C. Since R is a domain, there are no zero divisors. So A minus B is 0, or C is 0. But C is not 0, so it must be that A minus B is 0, or that A is equal to B. And that's what we wanted to show. Great. Oh, I'm now noticing a slight error here in this theorem. Suppose R is a non-zero commutative ring. I'll have to go back in and fix the notes. Nevertheless, that's the forward direction. Okay. For our reverse direction, suppose that R not 0 is a commutative ring with the cancellation property. Okay, I'll say the cancellation law. The only additional thing that we need to check for R to be a domain is that there's no zero divisors. So we just need to check there aren't zero divisors. And then it will be a domain. Okay, well, suppose we have zero divisors. So suppose there exists A and B in R with AB not 0, yet AB equals 0. Well, another way of writing AB equals 0 is AB is A times 0, because we proved that the product of any element with the additive identity is 0, so the right-hand side hasn't changed. And since A is not 0, and the cancellation law holds, it must be that B is 0. But B is not 0, and that's a contradiction, right? Up here, we're contradicting B being not 0. Okay, so therefore there are no zero divisors. In particular, R is a domain. Let's go down a little bit. Great, that completes the proof.